Hello everyone, welcome to Chem 9 lab session. This week we will conduct experiment number 10, and this experiment is related to solutions. The purpose of this lab is to determine the concentration of a solute in a solution, and we will also learn about the effect of a solute on the conductivity of the solution. Remember, in the lecture portion, we learned that many ionic compounds act as electrolytes, and covalent compounds act as non-electrolytes. So in today's experiment, we will see a variety of solutes. Some of them will behave as an electrolyte, and some of them will be non-electrolyte, and we will compare the conductance of various electrolytes. We will also learn the effect of concentration on the conductivity of that solution. So let's dive in. So as usual, the experimental procedure is given in the first tab here, and and the videos related to this experiment are given in the next two tabs. In this tab, you will find a video which explains about how to measure the concentration of any solution. We will need to measure the mass percent as well as the molarity, and in next tab the video explains us how to use the volumetric glassware, especially pipettes, to measure any specific volume of a solution. All the data needed to complete this lab report is given in this sample data, and we will use this sample data to complete the lab report, which is present in this last tab. So let's first take a look at the experimental procedure. Okay, so the objective of this lab is to calculate the percent by mass of a saturated sodium chloride solution, and then we need to calculate the molar concentration, which is also known as molarity, and then we will understand why some solutions conduct electricity, and that's where the concept of electrolyte and non-electrolyte will come. And finally, we will determine the effect of concentration on the conductance of the solution. So the formula needed to calculate the concentration are given here. So the first formula is mass percent, or mass over mass percent. It is given by grams of solute divided by the grams of solution times 100. And the molar concentration, which is also known as molarity, is given by moles of solute divided by liters of solution. So these are the two formulas which we will use to calculate the concentration of our sodium chloride solution. In part 2 of this lab, we will compare the properties of electrolytes and non-electrolytes on conductivity. In this section, we have various solutions given to us, and we will measure the conductance. And from the conductance of electricity, we will determine whether a solution contains an electrolyte or a non-electrolyte. And in the part 3, we will see the effect of concentration on the conductance of that solution. One thing I would like to mention here is that the instructions from step number 1 all the way up to step number 19. So all these instructions are given for a specific conductivity meter which can be used to measure the conductance. But we are not actually using this meter, so you don't have to read or you don't have to understand all these instructions, because we don't even have that meter. All the data which we would have obtained from this conductivity meter is already provided. All we're gonna do in this lab is we will plot a graph, and I will show you how to plot a graph using Excel. we will not use this program which is explained here. We will use Excel to plot a graph, and then we will use that graph to conclude which solution conducts more electricity, and we will complete our lab report using our Excel plot. So please ignore these instructions from step number 1 all the way up to step number 18, or in other words, all the instructions in part 3 are not really meant for us. Okay, so let's first see what are these 3 parts. So let me briefly explain the 3 sections of this lab. In part 1 of this lab, we are going to measure the concentration of NaCl solute present in a saturated solution. So in this experiment, we will determine that how much solute is present if we are given a saturated NaCl solution. Saturated NaCl solution means that it contains maximum amount of salt or NaCl which can be dissolved. It already contains that. So how do we determine that? So what we are going to do in this experiment is that we will take an empty container and we will weigh this empty container, and then we will add our sample solution into it, about 5 ml, and then we will weigh it again. Okay, so first we have mass of empty container, and now when we weigh it again, now we have mass of container or empty plus NaCl, so together. So from these 2 masses, I can calculate the mass of NaCl solution. So that will be given by mass of empty plus NaCl. If we subtract a mass of empty from it, so that will give me the mass of my NaCl solution. So now I know the mass of NaCl solution. So then what I will do is, or what we are going to do is, we are going to heat this NaCl on a hot plate. So when we heat this solution up, so what will happen is that the water will evaporate. So water will evaporate, and after some time, if we let it continue, if we let it heat, after some time all the water will evaporate and we will left with some powder here. So this is solid NaCl because all the water is gone now. So then what we're gonna do is we're gonna take this container which contains the solid powder, and we're gonna weigh it again. So when we weigh it, we will get the mass of empty dish plus the NaCl powder. Okay, so earlier we had the NaCl solution, so remember the distinction. So now we have the mass of empty plus the NaCl powder. So if we subtract the mass of empty from it, we will get the mass of NaCl powder. So mass of NaCl powder will be equal to mass of empty plus NaCl powder, which we just measured, this one, minus mass of empty only, which we measured in the beginning of this experiment. So now I know the mass of my powder, I know the mass of my NaCl solution. So using these two masses, I can calculate the mass over mass percent. So this is equal to mass of NaCl powder, which came from here, so this value here, divided by mass of NaCl solution, which we measured in the beginning. So this number goes here, multiplied by 100. So this formula will give me the mass of NaCl, mass over mass percent. So that's part number one. And in the same part, we also need to calculate the molarity. So molarity is equal to moles of NaCl divided by volume in liters. So remember, this volume should be in liters. We already know the mass, so we already calculated the mass here. So convert this mass to moles first. You already know how to convert mass to moles, so convert the moles. And we know the volume because we took 5 ml. So convert this 5 ml convert it into liter, and then use that volume here. So use the mass of NaCl powder and calculate moles from the mass, and then we took 5 ml volume. In some experimental data, you may have different volume because the data changes from one student to another. You may use, instead of 5 ml, you may use 10 ml or some other volume. So use the volume which is given to you. So calculate the liters from that, milliliters, and then use that volume in here and calculate the molarity. So this is part one of our experiment. In part two, we will classify if our solution is electrolyte, in case if it's electrolyte, we will have to tell if it's a weak electrolyte or strong electrolyte, or if our solution is a non-electrolyte solution. So to measure this, we have I believe 10 different sample solutions. For example, one is NaCl solution and soap solution and so on. So all the solutions are listed there, and we will use a instrument which has a light source here and then power source here, and then electrodes are here. Now as you can see that the circuit is not complete because the positive terminal is not connected to the negative terminal, so there is a gap here. So we are going to fill this gap with these solutions. So we're gonna pour these solutions in here one by one. If the solution conducts the electricity, the light will glow. So if this solution conducts the electricity, so charge is conducted across, then this light will start glowing up. And that kind of solution is known as electrolyte solution. Now electrolyte could be two kinds, either weak or strong. Weak electrolytes conduct lesser amount or little electricity and or small charge, and strong electrolytes conduct a large amount of charge, so therefore the light bulb will glow strong. And non-electrolytes do not conduct electricity, so they will not glow. So in our data, so we have used a special instrument. So in that case, no light of course means that our solution is non-electrolyte. But if it's a strong electrolyte, then the light will be green. If it's a weak electrolyte, then the light will be red. So if the red light glows, then it's a weak electrolyte. If the green light glows, then it's a strong electrolyte. So data is already given to us, so we will use that data and we'll see which of the sample solution is a weak electrolyte and which one is a strong electrolyte. In part 3, we are going to plot conductivity versus concentration plot or graph, and the graph will look like this. So conductivity will be on the y-axis and concentration will be on the left. The concentration will be on the x-axis. And there are 3 different solutions. The data is already given. All we need to do is plot a graph, and then after plotting the graph, we are going to fit the graph and we are going to find a parameter called slope. I'll show you how to calculate the slope and how to measure or how to plot the graph in a little while, but let's understand what that means. Before we learn how to plot a graph, let's take a look at the data. So the sample data needed to complete the lab report is given in this tab. So let's open it. And you will see that we have sample data for all 3 parts. For part 1, where we are calculating the mass over mass percent of solute sodium chloride. So all the mass values are given. For example, mass of the container, which is evaporating dish and watch glass, that's the empty container, is given. So a range is given, 50.75 to 50.90. So what that means is that you can pick any number within this range. You may pick 50.79 or 50.81, whichever you like, any number within this range. Then volume, as I mentioned, it's gonna be 5 ml. So volume of NaCl is 5 ml. And after we add this volume of NaCl solution to our empty container, now the combined mass is anywhere between 57.35 to 57.45. So pick any number within this range. And then we, as I explained, that we are going to evaporate it. So after evaporation, the mass of the dish and the powder is this much, any number within this range. So from these numbers, we can calculate the mass over mass percent and mass or the molarity, as I explained earlier. For part 2, the data given is whether the light was turned on or not turned on. For distilled water, no light. Remember, no light means it's a non-electrolyte. Green light means it's a strong electrolyte, and red light means it's a weak electrolyte. Okay, so in case of strong electrolyte, both red and green lights will work, but if only red light works, then it's a weak electrolyte. All right. So for example, in case of HCl, both red and green lights are on, so therefore it means it's a strong electrolyte. Soap solution, on the other hand, there is no light, so therefore it's a weak electrolyte. So we will use this data to figure out which of these solutions contain a non-electrolyte, which of these contains strong electrolyte, and which of these contains weak electrolyte. And for part 3, we have 3 different sample solutions. The first one is sodium chloride, second one is aluminum chloride, and third one is calcium chloride. And for all these 3 solutions, conductivity values are given. So these values were measured by a conductivity meter. So after adding 1 drop of sodium chloride solution, the conductivity value was 95. After adding 1 drop of aluminum chloride, the conductivity value was 280. And after addition of 1 drop of calcium chloride, the conductivity value was 127, and so on. So we are going to plot the data, this data. We are going to plot the number of drops versus the conductivity for all 3. So I'll show you how to plot it, and then we are going to calculate the slope, and we'll use the slope values to calculate further parameters. So let's take a look at how we are going to plot this data. I'm not gonna plot exactly this data, but I'll plot something similar. Okay, so for plotting, you will need Microsoft Excel, which is part of your Microsoft Office. So let's open Microsoft Excel. So open any worksheet. So let's, for example, I plot, so we can write number of drops in this column. So 1 drop, you don't have to write drop, just the numbers 2, 3, 4, 5, and 6. I'll stop here, but if in your case you have more data, so you can continue writing more numbers. And then on the second column, we'll write conductivity. I'll use some hypothetical values, but you have to use the data provided to you. For example, in this hypothetical case, maybe my first value was 24, and then next is 47, 72, and maybe 99, 121, and maybe 144. So I just made up these numbers. Okay, so if now how to plot this data. So first you have to write your data in columns. So the x-axis data should be in first column, and y-axis data should be in the second column. In order to plot the graph, so highlight your data. So select your data, make sure not to select that number of drops and conductivity, just the data, and then click on insert, and the middle tab here is chart. So these are various kinds of charts we can plot. I would like you to plot this one. This is called scatter. If you click on this tiny arrow, you'll see various kinds of scatter, and just if you scroll your line, it will show you what kind of plots you can make. But I would like you to plot the first one without the lines. So click on this plot, and now it has already plotted the data. So x-axis is the number of drops, and the y-axis is the conductivity. We can edit the plot if you want to. You can change the color and style, all those things. It's unnecessary at this point, so we're gonna leave it this way. So we can write what's the x-axis, y-axis value. So those are not needed at this point. So the only thing needed is what's the slope value. So for that, you need to click on these data points. It will select all the data points, and then you bring your cursor on the data and do the right click, and this window will open, and you need to select add trend line. So click on add trend line, and it will show you various options, and most likely it will select linear. If the linear is not selected, please select the linear, and then down here, so you need to select display equation on the chart. So select this one, and close it, and you will see an equation, and the value which is right next to the x number, that is our slope. So in this case the slope is 24.257. So in your case you will need to plot number of drops versus the conductivity of sodium chloride, and then fit the linear curve and then note down the slope value for sodium chloride. Similarly, you will plot for aluminum chloride. Again, you will do the same exercise to calculate or to measure the slope, and finally you will plot the calcium chloride data. So this one, so you need to use this column and this column, and that's how you will measure the slope values for all of these three solutions. Once you note down the slope values, then let's go to the lab report and see how to use these numbers. So let's open the lab report. Okay, so part A, use the mass values of all. The empty dish and the volume was 5.00. Okay, and similarly mass of evaporating dish, you get the value from the data and calculate the mass percent as I explained earlier, and the moles and molarity value. So that's part A. So part 2 is you select the data. For example, for distilled water there was no light, so select no light. For soap there was no light, so select no light. So whatever it says in the data, select accordingly and then answer these questions. These are simple questions. And part 3, enter the data. So this is the data which you get directly from the sample data. Enter the values and then enter the slope values in these three sections. And then regarding the appearance of each three curves, what kind of mathematical relationship, linear or inverse, it will be linear, so you can select linear. Write the chemical equation of dissociation. This we already learned, and in previous lab also we use this dissociation equation. So write down the dissociation equation, and then which graph had the largest slope value, so choose accordingly. So I'm not gonna reveal the number at this point, so you have to use your own slope values and then select whichever gave the largest slope value, or they may all be same, so we don't know. And then which graph has the smallest slope value, there we go. And since all solution had the same original concentration, what accounts for the difference in the slope? So the starting value of concentration is exactly the same, and if the slope values are more in one case or the other, you need to come up with a reason why any particular solution has higher slope or higher conductivity. And based on that information, you need to predict what will happen if you repeat the same experiment but use potassium nitrate and compare to which slope this potassium nitrate will match. And similarly you need to predict for chromium nitrate also. And then you hit submit and we are done with this lab. If you have any question, please feel free to contact me. Have a wonderful rest of the day. Bye-bye.